Hi everyone, welcome back to the channel. In today's video I'm going to be looking at a Pioneer XEM22 CD player cum radio. The problem with it is it's dead. This is plugged in, there seems to be no life whatsoever. First thing I'm going to do, I'm going to plug it out of the mains, and I'm going to just double check the plug first and see how we go from there. I got the top off the plug, and I'm just going to double check this fuse. Everything seems okay in here. Got 13 amp fuse, a bit high for what it should be, and why that is I don't know. Maybe the customer that brought this in changed that fuse. And obviously that fuse is okay. And I'm going to do a resistance read now between the live and neutral. Did we get anything? And we're getting 1.4 mega ohms. Now, I don't know what that means. Most likely it means my cable is okay. And right, what I'm going to do now is I'm going to take the top off this and go from there. Okay, I'm going to check continuity between the live here and the live going in here. Actually, we can check both things at the same time. This here is a fuse, so what we can do is check this side of the fuse. So that fuse is okay, and the brown wire, the live wire, is okay. Right, just double check here between the neutral. Okay, so we have continuity up to there. What do we do next? All right, I'm going to have to take this board out now and see have we got any voltage on this capacitor here. I have to be very careful. This capacitor might be charged up, and I will have to discharge it before I do any work. I would imagine this is possibly the transistor, switching transistor. I don't know, I'm just surmising. Here's your bridge rectifiers, these 4 diodes here. Your mains filter input, fuse, boxes. It's got all the usual standard things on the input of a power supply. Okay, I'm going to take out this board now and have a look. I have it plugged into the mains, and we're going to just check across this capacitor again together and see what there is. Okay, we have 330 volts there. Okay, that's looking good. Next thing I'm going to have to check is there any secondary voltages? Do we see anything? Find the ground plane. I'm just being very careful with this because it is live mains we're working at the moment. I know it's over that side, this side is okay, but you can forget yourself. Okay, that looks like a ground point there. And you just see diode here. Okay, we have 12 volts here. Well, minus 12 volts, and it seems to be going up and down. That's not good, is it? Not very stable. Do we have a capacitor on the primary side, a startup capacitor? All right, is there any other diodes? That's a funny looking reading. I'm going to go with, most likely, there could be a short somewhere, or we could have a capacitor on the primary side going low in value. That's what I'm going to go with first. I could be wrong, but we'll see. I see a capacitor here standing out here by itself. That's the first place I'm going to look at. I'm just going to take that out, unsolder it, and double check it on a capacitance meter. Or I just might replace it and see what happens. It might be a lucky, easy job. I've changed this capacitor here on the primary side of the power supply, and there was nothing wrong with the capacitor. It was reading 22 microfarads. But what I'm getting here is on this, okay, the same thing, going up to 12 volts, and it's going up and down. I've checked for shorts on the secondary side. I'm going to see, can I get some kind of schematic on this and see what it is. There is a chip on it there. I don't know what it is. It could be that. I don't know at this stage. On the secondary side, we have, let's see, get my leads, working point. On these two main chunky diodes, well, it's varying between 11.8 volts and 13 point something volts. Maybe if I put an oscilloscope on that, maybe I got a ripple on the secondary side. I got that there. Nothing on this capacitor, which is odd. Nothing on that capacitor either. Another varying voltage there. I think what I'll have to do is I'm going to have to try this, have a look at this capacitor here as well. Make sure that hasn't gone on it. I'm going to have to get a schematic for this. Working in the blind is not good for this type of fault. I'll also have to look at that IC, see what type it is, see can it be got. And if it can be got, orders. Because some of the time it can be as simple as that chip there. And you won't see anything faulty. I've checked for shorts, shorted diodes. These capacitors on the primary side look, or sorry, on the secondary side look okay. No ripple on them, I can see. So let me double check. Can I find a schematic for it? I went online. I could not find any schematics for this. I could find the service manual all right that showed you how to strip it down, all the different boards and things like that, but no schematics whatsoever on that service manual. And checking for this number that's on this chip, 73G47A398. I could not find anything when I Google searched it. This diagram here, I just done a bit of reverse engineering. I don't know if it's 100% correct, so don't take it as it is that it is 100%. I've tried my best. But anyway, this here is the easy bit here. Here's your mains in, your fuse, F300, 1.5 amp, your choke. As you see, I had to make these up because the free software for the schematic drawing software that I've got didn't have everything that I wanted in there. So I had to make up some of these symbols. And bridge rectifier, and here we have this our 380 volts going into your primary side of your transformer, comes down and through a coil FB300 and down to our main switching MOSFET. Down here then we got 3 current sensing resistors, 2 of them are 2.2 and one of them is 1 ohm, odd one, but it's an odd one, but that's what it has. And this is your feedback here, and I would imagine this is your overcurrent sense on pin 4, that little IC. Okay, and here is your to start up this chip. You have these 3 high value resistors here at 330k a piece. And what I'm getting down here, as far as I remember, it's been a week since I looked at it. I think this was going up and down between, say, 10 and 12 volts. I can't remember now, but it was varying. We did have a voltage. I did replace this this capacitor here, EC301, 22 microfarad, and there was no problem with that. Okay, what I had here then on the secondary side, as far as I remember, I had 12 volts, varying here between 12 and 13 volts or something. I know it was 11 and 13 volts was going up and down. And then I think on these 2 capacitors here, I could find nothing. I didn't mark in this capacitor here, but no, how far I can't keep going. It's a lot of work to reverse engineer a PCB, especially a double-sided print one. There's people that do it, but they do it as for a living. Of course, we have this here, this feedback here from the secondary side. I didn't draw in all that stuff yet. Maybe I will if I have to later on. And it goes back to pin 2 of this. Pin 1 is ground. Here. This looks like some kind of snubber network here. These diodes, resistors, and capacitor. Anything else you can see there? Here's your drive coming out with pin 6. And that's all I know so far. I'm going to use this as reference now to see can I fault find on that. But I'm kind of hedging my bets on this at this stage. But I've also thinking here on the secondary side, as far as I remember, there was no voltage on some of these. And then I'd have to ask why is there no voltage on these when there is voltage on this one here? There should be some kind of voltage. But as yet, I don't know what these voltages are. Are they very low voltages? And they're only going to go up to, say, 0.1 of a volt, 0.2 of a volt, while this one here is a higher voltage one. But being a CD player, you're not going to have 100 volts anywhere on this. These are all going to be 12, 15, 24 volts. They're not going to be high voltages as such. I see we have a minus supply and a plus supply. Maybe that goes to some kind of op amp somewhere on the board. It needs the plus and minus supplies. Okay, I'm going to check these here, the supply here. I've already checked the value of these resistors and they're all okay. And every resistor you see marked up in here, I have checked. So I've ruled all that out. So first of all, here we go, after these 3 resistors. We're on ground. And we can see that's pumping at the same time, which really means I'm possibly not getting any secondary voltages on this at all. And let's go back to the diagram. I want to check here now, just at this diode here and this capacitor. But really they're all connected together, as you can see there. It shouldn't be any different. But anyway, let's do it for the sake of doing it. Okay. What we got? We still got our voltage jumping from 11 up to 14 volts. I'm going to now check here with the oscilloscope on the secondary side. I know these were going up and down at the same time as this voltage was going up and down. Careful not to forget that's plugged in. And here's them 2 diodes. And let's see what we get on our oscilloscope. And that's all we're getting. A little bit of action there and back down again. and that's millivolts. I've checked on the secondary side, there's no shorts. All the capacitors are okay, they were checked okay on the meter. I'm left with no option now but to check, possibly condemn that chip and a small 6-legged chip there, which I can't find anywhere. Let's see what kind of drive we got. Now for this I'm going to just plug it out temporarily. I'm going to stop the recording and I'll do that. Okay, it's plugged back in. I got one lead connected to ground, and I don't really need an isolation transformer for this oscilloscope, but if I was using the mains connected oscilloscope that's grounded, I would need an isolation transformer at this point, because the this lead here is connected directly to ground. Okay, and what we got a drive here. We got something there, haven't we? It's doing auto. It's like it's gone into either over current or over voltage mode. It's just coming up and going. Why that looked like a nice healthy waveform. It doesn't look so good now, just looking at it. Now I won't connect this to the collector, the high voltage end with this oscilloscope, because it's wouldn't be able to cope with the higher voltages. Well, I wouldn't like to chance it. I don't know what the rating is on it, but I can find nothing wrong with the secondary side, and all the resistors here on the primary side read okay. And there's not much to the primary side if you look at it. The transformer windings are all intact. There's nothing open circuit there. I've used my thermal camera on it to see if there's any hot spots, and the only hot spots I can see is the 3 resistors, the 3 startup resistors down here. They're the only 3 resistors I can find are getting hot. We're not really getting much there now. Let's check that out again with the multimeter. Can we get both of them in there? Okay. That's what it's showing, about 14 volts. Just to conclude this video now, if I do find out more about this, I will have a part 2 of it. But for now, I can't find any shorts on the secondary side. That I can see. There's no hot spots on the secondary side. I can supply voltages on the secondary side. I don't know what these voltages are, but they're going to be no more than 12 volts. I would imagine 15 volts at the max. But I'm only putting about 2 volts into it, 1 to 2 volts, and it's drawn no current whatsoever on the secondary side at that voltage. And if there was a short, no matter what voltage you put in there, you would have current being drawn. So I don't know where I'm going from here. I'm going to dig a little bit deeper into it, because it's like a short. But I've seen this with those little drive transistors or drive ICs as well, giving the same symptom as this, and you could spend your life trying to find a fault on it that doesn't exist on the board apart from that chip. So right, I don't know where I'm going from here. I'll double check my work now and see if I missed something.